Hi again. Let's say I have an electric dipole, a positive charge. Let's say the positive charge is to the right. I have a negative charge here, an electric dipole, so it's minus Q and Q. And here I have Q. And the distance between them is D. Okay, the total distance is D between them, or 2D. Let's say half the distance is D. All right. The question is, and the electric field exactly midway between them. The electric field midway between them is, let's say, E. That's the electric field exactly midway between them. So I'm gonna draw it here. It's gonna be E, and for sure it's directed to the left, because this E is the result of two electric fields, an electric field due to the positive charge and the electric field due to the negative charge. Same electric field. When we add them, you will get a total electric field, which I'm gonna call E. So the question is, I would like to find the electric field at a point to the right of Q, which is at a distance D. I would like to find the value of this electric field here. I'm gonna call E prime. I want to find it in terms of E. So how do I solve such problems? Now, to start solving such problems, let's find E. What will be the value of E in general? So E is going to be, as I said, the sum of the electric field due to the positive charge, which is KQ over D squared, because again, the distance from here till here is D, and the distance from here till here is also D, plus the electric field due to the negative charge, which is also KQ over D squared. I'm using magnitudes. So E is going to be 2KQ over D squared. That is E. Let's put it in a box. Now, E prime, again, it's the sum of the electric field due to the positive charge, which is going to be to the right, and it's going to be a strong electric field. Or let me draw it like that. And an electric field to the left due to the negative charge, which will be smaller than that to the positive, because the negative is far away from this point. So this E prime is going to be the red electric field, which is KQ over also D squared, plus the electric field due to the negative charge, which is also K, or minus, not plus, because it's in the opposite direction. So minus KQ. Now what's the distance between the negative and this point? It's gonna be 3D over 3D squared. So it will be 9D squared. All right, so let me write it first as a 3D squared, like that. 3D squared. It's gonna be 9D squared. 9D squared. Now how to add those? So I multiply here by 9 and by 9. And what we will get is the following. 9 minus 1 is gonna be 8KQ over 9D squared. When they ask us to find the new electric field, or E prime, in terms of a certain electric field E, the easiest way to do is use the ratio technique. So you write E prime over E. We use the ratio technique because we are going to cancel the similar terms. So E prime is 8KQ over 9D squared, and E is 2KQ over D squared. Now we cancel the similar terms, KQ with KQ, D squared with D squared. So we will get, you multiply this one by this one, you will get 8. And here, 9 by 2, you are going to get 18. So 8 by 18, we can simplify it. So E prime over E is going to be 4 over 9. So what will be E prime? Cross multiply So it will be 4 over 9. You take e to the other side, it will be 4 over 9e. So this is how we find e prime in terms of e using the ratio technique. Thank you for watching.